Did you know that every star you see in the night sky is actually bigger and brighter than our Sun? Among the approximately 5,000 stars brighter than magnitude 6, only a few very faint stars are about the same size and brightness as our Sun. The rest? They're all significantly bigger and brighter. Fascinating, isn't it? Have you ever gazed up at the sky on a clear summer night, marveling at the sheer number of stars? How did it make you feel? If you thought that was a lot of stars, just wait until you see the stunning images taken by the James Webb Space Telescope of star clusters. Don't forget to like this video and subscribe to our channel for the latest updates on the James Webb Space Telescope, NASA news, and other exciting space discoveries. Now, let's dive in. This image of the cluster Westerland 2 and its surroundings, captured by the observatory, is absolutely breathtaking. Westerland 2 is a compact young star cluster in the Milky Way, with an estimated age of about 1 to 2 million years. It contains some of the brightest and most massive stars known. Located 20,000 light-years away in the constellation Carina, the cluster resides inside a stellar nursery known as GUM-29. Discovered by Bengt Westerland in the 1960s, the full extent of its stellar content was only realized in later years. Isn't it amazing how much more there is to discover about our universe? Number 2. Extreme Star Cluster. The star-forming region NGC 3603, seen here in the latest images taken by the observatory, contains one of the most impressive massive young star clusters in the Milky Way. Bathed in gas and dust, the cluster formed in a huge rush of star formation thought to have occurred around 1 million years ago. The hot blue stars at the core are responsible for carving out a huge cavity in the gas, seen to the right of the star cluster in NGC 3603 center. Number 3. NGC 1866. Star clusters are common structures throughout the universe, each made up of hundreds of thousands of stars, all bound together by gravity. NGC 1866 is found at the very edges of the Large Magellanic Cloud, a small galaxy located near the Milky Way. The cluster was discovered in 1826 by Scottish astronomer James Dunlop, who catalogued thousands of stars and deep sky objects during his career. However, NGC 1866 is no ordinary cluster. It is a surprisingly young globular cluster situated close enough to us that its stars can be studied individually. There is still a debate over how globular clusters form, but observations such as this have revealed that most of their stars are old and have low metallicity. In astronomy, metals are any element other than hydrogen and helium. Since stars form heavier elements within their core as they carry out nuclear fusion throughout their lifetimes, a low metallicity indicates that a star is very old, as the material from which it formed was not enriched with many heavy elements. It's possible that the stars within globular clusters are so old that they were actually some of the very first to form after the Big Bang. In the case of NGC 1866, though, not all stars are the same. Different populations or generations of stars are thought to coexist within the cluster. Once the first generation of stars formed, the cluster may have encountered a giant gas cloud that sparked a new wave of star formation and gave rise to a second, younger generation of stars, explaining why it seems surprisingly youthful. Number 4. NGC 3201. This image, taken by the observatory, reveals a glistening and ancient globular cluster named NGC 3201. It is a gathering of hundreds of thousands of stars bound together by gravity. NGC 3201 was discovered in 1826 by the Scottish astronomer James Dunlop, who described it as a pretty large, pretty bright object that becomes rather irregular towards its center. Globular clusters are found around all large galaxies, but their origin and role in galaxy formation remain tantalizingly unclear. Astronomers recently discovered a black hole lurking at the heart of NGC 3201. Its position was revealed by the strange movements of a star being quickly flung around a massive invisible counterpart. This sparkling group of stars also has some strange properties, which make it unique amongst the 150 globular clusters belonging to the Milky Way. NGC 3201 has an extremely fast velocity with respect to the Sun, and its orbit is retrograde, meaning that it moves speedily in the opposite direction to the galactic center, which it orbits. The unusual behavior of this cluster suggests that it may have extragalactic origins, but was captured by the Milky Way's gravity at some point. However, the chemical makeup of this intriguing cluster tells a different story. The stars within NGC 3201 are chemically very similar to those of other galactic globular clusters, implying that they formed at a similar location and time to their neighbors. Whether this mysterious cluster was adopted by our galaxy, or has for some reason evolved very differently from the family of clusters it grew up with, it is certainly an unusual astronomical beauty. Number 5. The Mammoth Stars. The image shows a pair of colossal stars, WR25 and TR16, located within the open cluster Trumpler-16. This cluster is embedded within the Carina Nebula, an immense cauldron of gas and dust that lies approximately 7,500 light-years from Earth in the constellation of Carina. WR25 is the brightest, situated near the center of the image. The neighboring TR16244 is the third brightest, just to the upper left of WR25. The second brightest to the left of WER25 is a low-mass star located much closer to the Earth than the Carina Nebula. Number 6. Panoramic view of star-forming 30 Doradus is the brightest star-forming region in our galactic neighborhood and home to the most massive stars ever seen. The nebula resides 170,000 light-years away in the Large Magellanic Cloud, a small satellite galaxy of our Milky Way. No known star-forming region in our galaxy is as large or as prolific as 30 Doradus. The image comprises one of the largest mosaics ever assembled. Number 7. Stars on a diet. The star cluster Pismis 24 lies in the core of the Large Emission Nebula, NGC 6357, which extends 1 degree on the sky in the direction of the Scorpius constellation. Part of the nebula is ionized by the youngest, bluest heavy stars in Pismis 24. The intense ultraviolet radiation from the blazing stars heats the gas surrounding the cluster and creates a bubble in NGC 6357. The presence of these surrounding gas clouds makes probing into the region even harder. One of the top candidates for the title of Milky Way Stellar Heavyweight Champion was, until now, Pismis 24, 1, a bright young star that lies in the core of the small open star cluster, Pismis 24. That is the bright star in the image. Its distance is about 8,000 light-years away from Earth. Pismis 24, 1 was thought to have an incredibly large mass of 200 to 300 solar masses. New research of the star has, however, resolved Pismis 24, 1 into 2 separate stars, and in doing so, halved its mass to around 100 solar masses. Number 8. Messier 2. Star clusters are commonly featured in cosmic photo shoots and are also well loved by the keen eye of the observatory. These large gatherings of celestial gems are striking sights, and the subject is Messier 2. Messier 2 is located in the constellation of Aquarius, about 55,000 light-years away. It is a globular cluster, a spherical group of stars all tightly bound together by gravity, with a diameter of roughly 175 light-years, a population of 150,000 stars, and an age of 13 billion years. Messier 2 is one of the largest clusters of its kind and one of the oldest associated with the Milky Way. Most of the cluster's mass is concentrated at its center, with shimmering streams of stars extending outwards into space. It is bright enough that it can even be seen with the naked eye when observing conditions are extremely good. Number 9. A symphony of colors. The tarantula is situated 170,000 light-years away in the Large Magellanic Cloud in the southern sky and is clearly visible to the naked eye as a large milky patch. Astronomers believe that this smallish, irregular galaxy is currently going through a violent period in its life. It is orbiting around the Milky Way and has had several close encounters with it. It is believed that the interaction with the Milky Way has caused an episode of energetic star formation, part of which is visible as the Tarantula Nebula. Just above the center of the image, there is a huge cluster of very hot stars called R136. The stars in R136 are also among the most massive stars we know. R136 is also a very young cluster, its oldest stars being just 5 million years old or so. Its smallest stars, however, are still forming, so astronomers observe R136 to try to understand the early stages of stellar evolution. Near the lower edge of the image, we find the star cluster Hodge 301. Hodge 301 is almost 10 times older than R136. Some of the stars in Hodge 301 are so old that they have already exploded as supernovae. The shockwave from this explosion has compressed the gas in the tarantula into the filaments and sheets that are seen around the cluster. Number 10. A rainbow of stars. This spectacular image shows the Large and Small Magellanic Clouds, which are two irregular dwarf galaxies that orbit around the Milky Way. These galactic neighbors, which look like bright smudges in the southern hemisphere sky, have been known since ancient times and feature prominently in southern hemisphere mythology. The image of these companion galaxies provides new insight into how stars form and evolve. The Milky Way is a barred spiral galaxy composed of stars, gas, dust, and dark matter. Its name is derived from its appearance as a dim milky band of light stretching across the night sky. This band of light is the combined glow of the millions of stars in the disk of our galaxy that cannot be individually distinguished by the naked eye. All right, folks, make sure you like this video and subscribe to our channel to stay updated on the latest from the James Webb Space Telescope, NASA, and other space news.